I hope you're ready for this. This is not only the most exciting part, but at the same time also the most difficult part. So in one way, we can be happy that we learned something that is really, really interesting. But on the other hand, it might be a little bit tedious because these things don't become clear right away, especially if you're not used to writing asynchronous code with multiple threads and are still taking your first steps in those kind of fields. I myself have not written quite a lot of code in that department, so that's the reason why I literally sent the code snippet to the engineer that has conceived TMS XData and say like, hey, is this approach for multi-threading the correct approach for TMS XData? Is this something you would implement yourself? And he agrees. In this case, that's how I would tackle it. The reason why it is so difficult will become clear right away as soon as you look at the code, how it needs to be done according to FNC maps. Because just let me create another form in here. Form, and for whatever reason, this is the best hidden, the form nowadays is the best hidden component here. I think it's on the Windows, and then I have to scroll down. There we go, VCL form. And let's drop a FNC directions, okay? Poof, right here. And I have events here, for example, the get directions, on get directions result. That's the key here. This event is triggered when direction results are retrieved. And that should ring a bell in your head, because if I implement something here, let's call this component directions, and I go here, directions dot get directions right here, I would have to call this. I can specify an origin, a destination, and a callback. Or I don't specify it, I'll leave it nil, and then the component will call this event right here. And that's exactly the difficulty. Imagine that you write a method in your web service that calls get directions, and then it has to wait until the result from the callback is retrieved. So at this point, if we look at the code, we have, Wagner, the engineer that wrote XData, Wagner Landgraf, and I basically said there's two real options how to implement this, and we decided for that one of them, obviously. Maybe you come up with more, but those are the two that made the most sense to us. But looking at the implementation, we have the method get driving directions. We get an origin and a destination as a string, and we need to return a route. That's what we need to use. By default, our result is nil, meaning we don't have anything from Google yet. That is literally something that can happen. If you specify how can I go from Miami, Florida to Seattle, Washington, you might not get a reply in a certain amount of time. That is something you also have to remember. You're working with a Google web service on the back end of your backend, so to speak, and that might not deliver a reply. So nil is definitely a viable response for this thing. In order to identify the request that we sent to Google, we need to generate some sort of ID. And in this case, I simply generated a UID, a unique ID. That's, to me, the easiest approach, so to speak. We do need this because there is no guarantee that get driving directions is not called multiple times at the same time, because multiple people can use your web application at the same time, and people can issue requests to your web service at the same time. That means there is parallel runs of this get driving directions method. That is just something that might happen. So you need to be able to distinguish later on which request you're dealing with. And this is not only the instance, if you look at the multiple threads, this is also something that is built into the get directions, because there the third parameter actually right here. This origin is the first, destination is the second, the callback is the third, the fourth is the ID of the request. So you can identify it where, well, if your callback gets called here, this is your callback right here with the request and the request result. There, you also can read the ID so you know which request it is. So if you have later on multiple requests at the same time, each request to Google, those are the requests we're assigning an ID to, have a unique ID assigned to them. Everything separates into two tasks. The first task is to retrieve the information from Google. That's task number one. Task number two is wait for Google to deliver this result, or if Google does not deliver this result in a certain time, return 404 not found. That's the option we have here. Alternatively, you could also just shoot this get directions request off, and then instead of using some memory data structure to store the directions, you could also store this in a database or in a memory storage that is housed inside of your directions manager class. But that would require you, just to be very direct, that this manager is always the same for all the different requests that you do, that you do not use separate classes. And then you could have in your directions manager a data structure that holds all the direction requests and routes that have been requested. But again, you see, I'm going for the approach that is the least amount of work and is the easiest to understand at first. That's why we're not doing it. I'm not saying this is the most performant one, but this is one that works and is straightforward and is also, if you want to believe Wagner and I, the one that is reliable. There's a lot of trust here, right? But in all seriousness, this has not been conceived in 5 minutes, 10 minutes, 20 minutes, 30 minutes. This is something where I sat down and built the structure of this method and thought, like, what could I use? Because these tasks, of course, are a library that is bundled with Delphi now, the parallel library from Embarcadero. And after that, I did the thing, and this is exactly the point where it gets a little bit tricky. Let's say you have this task to retrieve, and you create this task, and this task does nothing else but, don't let you get confused with the syntax, we just pass in a procedure inside of the parameter of the constructor of the task. So the task will execute this procedure when started. That's the content of it. And inside of the procedure, we call f directions get directions. That is the component. Where does f directions come from? It's defined in the class here up. F directions is the component ttms fnc directions. That's the component that I've been dropping on the form each time. And I initialize it as follows. ttms fnc directions create nil. In this case, again, I want to free it myself. And then f directions API key. T API key is Google. I use my Google API key coming from this unit right here. And I am very much aware that I'm not showing it here. And then there might be people looking at the source code associated with this video and say, like, he has the key in the history. He made this public. And be assured, this key no longer exists that I used, that I checked into the source repository for my testing. I removed that key. I already replaced it with a different key. So even if I were to show it, I'm just not showing it because I don't know how YouTube analyzes these videos and it's like, oh, there's secret information in there. So I'm not even going to show it. I'm saving myself some time to blur it. So that returns a string with the key, and the service is Google. So with that, the direction service is initialized. It's the same thing as if you drop it on the form and assign the properties. So this directions component we call with get directions, the origin, the destination. They, of course, come from the parameters of the method. And then, and this is where my head was completely screwed the first time I looked at this. Of course, that is a callback. So we call get directions and tell it, give me the route from A origin to A destination. And when you have found a route, or if there's an error, basically if you're done with that, call this. That's what this means, okay? And that might be very, very difficult to read at first, but that's what it means. And the first implementation that I had was, okay, that's easy. So we have ltask retrieve, right? So we can say here, ltask retrieve start. So tell it to start. And then here we do task wait for all and say ltask retrieve. Boom. Looks fun, huh? Like that means like, okay, we start it, and when it's done, you know, we have all we need, and we can then basically pass the result on to somewhere else. The problem is this thing finishes right away. Why? The reason is we call f directions get directions and tell Delphi, call this method with these parameters and with this callback done. So Delphi immediately executes the next line, and that is the end of this procedure. So the task will be terminated and done with. So if we were to say ltask retrieve, wait, basically if we were to wait for this, it would finish right away and it would be gone. Ltask retrieve would be gone before the callback can even be called. So it would be done. You know, Google would most likely process the result and then send it back on, there's nothing there anymore, so done. That's definitely not what we want. If you're concerned about memory leaks, don't be, because it's an I task. So as soon as it goes away, Delphi will also handle the memory management. So there's nothing to be concerned about in that regard. It's just not going to work. Okay, you wait for something that concludes right away. So at that point, when you get after the waiting, you still don't have the result from the web service. So what we need to do is we need a task to wait. And this is, as I said, this is the one where the web service really is going to return a result. Alternatively, you could say, start this, return nothing, return the ID of this request, and then build a second endpoint into your web service where you say, get the data for this request. Of course, you don't know how long this takes. How long are you going to wait? 1 second, 2 seconds, 3 seconds, you know? And at that point, you need some sort of mechanism on the client where you ask for the same thing multiple times, as long as the result is don't have an answer yet. And then the answer is either could be retrieved, could not be retrieved. And if it's could be retrieved, you automatically return the root as well. And if it's could not be retrieved, that's also an answer for the web client. However, that implies that your web client needs to issue requests with a timer or something on a regular basis. I don't like that, because we're looking here at something of a maximum of 6, 7, 8 seconds to be retrieved. So it doesn't make any sense for me to build a client that polls on a regular basis, do I have an answer yet? Do you have an answer yet? Do you have an answer yet? If you can implement it like this without doing that. Basically, this service is easier to consume than something like start the process and then retrieve the process. One example for a service that would benefit from having started off and then basically get regular updates is, for example, imagine you have an accounting system and you do payroll and you have to generate the PDF documents for all your employees as PDF documents. And then you have a web service which downloads a zip file of all those PDF documents. Okay, just assume. Obviously, to create all those PDF files, if you work in a company with 5,000 employees, it's not going to be 5, 10, 20 seconds. It's longer, most likely. And that means it does not make sense for the web server to wait in order to return the result right away. So instead, you would basically trigger the generation of the reports and then have a second endpoint that would then basically ask which reports are ready or retrieve these reports. You would have a completely different interface to communicate with your web service than this. Okay, but we still don't have a result from the web service, right? We just called get directions, and we haven't looked at the callback yet. We also need a data structure that allows me to transfer data from this callback to here, to the outside world, basically. So what we do, we don't declare something locally. We say froots is a dictionary of roots identified by ID, as you can see it right here. So we have a dictionary. The string is the ID of the root, of the request, and then we have a root associated with it. So going back here, we get the directions for a origin, a destination, and please call this callback with a request and a request result. If you wonder how I get these wonderful fingerprints right here, I don't remember these. This is not something I can store. I click on get directions, say 3 Hail Marys, that Delphi will find it. And in this case, it does. And that's how I get these things, because then I can browse in the parameter list right here, a callback, click on the link, and here we go. TFNC direction, get directions, callback, reference to, and then here, there is my fingerprint. Of course, this is what I mentioned right at the beginning of this tutorial series. If you write your code for multiple platforms, you have these if-defs everywhere. So that is the downside. And that's why I opted for client, server, different. But here you see this is exactly the fingerprint that I used. So going back here, we get back the request information and the request result like status code. Request result indicates if it's successful. Just be careful. A successful request can also mean that no route exists. The request was successful. Like if I ask for a route from Florida to Dortmund, Germany, it's going to be successful. But the answer is there is no route. So we have to check a request and look at the items inside of request. This time, a request, not a request result. A request items count, and if that's bigger than 0, we have more than one route. In this case, I only look at one route. I wanted to keep it simple. Obviously, I could loop and not only add 1, I could create n, as many as are returned, because with Google you can also ask for alternatives. But by default, here, if you look at get directions and go way, way, way back into the parameter list, there's something like here, a alternatives Boolean, and that's by default false. So it only gives you 1, and by default it is the fastest, I think. So if you were to flip on a alternatives to true, you get 1 that is the fastest, the shortest, and these kind of things. With toll, without toll, here, you also can basically say avoid tolls to true, and these kind of things. That's all configurable. This is just the minimal solution I'm presenting here. There's so much more to discover, and if you're interested to discover, think about the fact that there is a book, TMS Maps, from me. In the end, I'm going to present all the learning content that is available as well, in addition to this tutorial. So if we have the item or more than 0, then take the first one. I love inline variables here. I mean, you will see in the web client when we look at that, how much easier and better the code becomes to read if you have this, compared to not having it. I mean, imagine having to go, where do you go now? Where do you declare a route? Well, you have to declare it here. Because, it's not a variable declaration for here either, right? Is it? It's like we have one function inside the function a procedure and another procedure. So having inline variables here makes the code more readable, and it's really just pointed to the first root in this case. We also create a root of our data model root, troot, and then for each step, and I named these Google steps because these are the steps inside of a root. So Google step is actually the data type that we get back from Google right here. So we have all these funny things, coordinates with TMS, FNC maps coordinates, distance, durations is the same, but these are the TMS map specific data types. So what I do now, and this is, again, I said, like, think about the data model first. I say L step, T step, create, and then I can say L step assigned from a Google step, boom, initialized, right? Data model first. And then I say L root add step. Yes, I created that for a reason, so we can add the step easily. And now the biggie. froots add a request ID a root. That's pretty straightforward. We want to, with the ID, and in this case, we can no longer use it from here, right? Because we need the request that has been returned, and that is here in a request. It's returned to us as a parameter. And in lroot is our troot. That's the one that we want to put on the dictionary with this key. Perfect. However, it might happen at the same time in a different thread. And remember, if you write to the same memory address from different threads at the same time, it's going to blow up. So what do? By the way, I'm not going to even try to give any real-life analogies. Some people do that. I'm not. I'm just going to say never access the same memory space in different threads at the same time without making certain that you have a semaphore in place. So what we do is we call tmonitor enter, and we pass as the tag froots, which is available in all the threads because it's like a field in the class that we use. So we lock it out, and what we do is we make sure that as soon as we enter the semaphore, we add it to the dictionary then, and then we make sure that the semaphore is being left with tmonitor exit. Very important, which makes certain that two requests do not access the same data structure at the same time. Obviously, at this point, our information, as it is in froutes, is also available anywhere in tDirections Manager, right? So what we need to do now is to have a second task which waits for the ID to be added to the dictionary and then return it to the client. And that's what ltaskWait does. To make things even more complicated, I created a future. A future is a function that might return a value at some point in the future, okay? And the type is of troot. So we have the fingerprint function, troot, and this looks like in the code completion looks like const func tfunc, right? And it's like one parameter that is being returned. So the function has no parameters. So the function has no parameters, but it returns a type troot, one of them. That's basically what's in there, okay? So the function returns troot. I just explained it. That's, again, an anonymous function passed as a parameter, just like with the other task. And what I do is I want to wait a maximum of 10 seconds. After 10 seconds, I want to bow out and say, hey, we don't have a root. Okay? That's the thing. So I'm going to try 20 times. So only if L times smaller than 20. And each iteration, I sleep for 500 milliseconds, which is half a second. And lroot, only as long as we don't have a root, right? That's why I initialize it here with nil. And as soon as we have a root, this loop is left. The while condition is no longer met. And L times smaller than 20. So that means when I'm done, I increase L times. So what do? In the semaphore, again, I check if froots contains the key. And if it does, I found my root. I can say lroot is froots lid. The root is in the dictionary. So think about it. This thing here iterates and sleeps for a maximum of 10 seconds. In these 10 seconds, this task up here, the callback can get called and fill or add the root with the ID to froots. If that happens within 10 seconds, this froots is going to contain LID. Again, LID is defined outside of the task. So LID here is passed to the request and is then in the callback read using a request ID here. It's passed as a parameter to the procedure. Yes. Think about it again. Rewind to here. Okay, we're back. Okay, so a request contains the ID that is passed to it as the second or fourth parameter actually after origin, destination, callback, AID. And it is initialized at the beginning of the method with a unique identifier. And then back here, we use it inside of another task. We use LID, it's captured. And we look, if froots contains the key LID, then set the current root to the root that is associated with that key. And all of this has to be wrapped in a monitor because don't touch something at the same time from two threads at the same time. You don't do that. So in this case, just make sure that only one thread accesses it. So we use froots as the token, so to speak. And I don't know what the parameter is called officially. They just call it a object. Interestingly, you can also do a timeout here that you say, how long do you wait for the basically for froots to be freed from another thing? I haven't looked into that so far. It's been very, very stable without any issues. And finally, we increase L times so that we only sleep a maximum of 20 times. 5 hours is 20 seconds. So that's basically all there is. So it might be possible that lroot stays nil. If this never gets called, it stays nil, and it needs to be returned. And this might be, wow, yeah, because this is a function, right? So the function needs a return value, which is lroot, and it can be nil if no root is found. Okay, so here, this is it. And now the biggie, I say result of the original get driving directions. Yes, we're finally at the end. Yes. Good. So at the end here, we say result is L task wait, that's this task here, dot value. What this does, it starts the task that we defined here. And if it already has started, which in our case, it hasn't because we don't have like anything like L task wait dot start or something, right? We don't have that. So we just say, read the value, which is the return value to root in this case. And if it's already available, which is very unlikely because like create the task and then ask us the value available, that could only be for future if you create multiple futures at the same time. And then, sounds great, huh? Create multiple futures at the same time, yeah? And the one that you created first is already done, for example, okay? But in this case, result is L task wait with value, and it waits. It literally waits until value has a value. And we made sure that it will be at least after 10 seconds. It's either going to be nil or it's going to contain the root that we need. But it will never be longer than 10 seconds. We make sure of that. And then if result is nil, meaning we do not have a root, we throw an exception, an XData HTTP exception, which sends status code 44, which is no root found, not found, and that's it. And otherwise, result contains our root. that's it. Okay? So there's two major things to consider here, to be honest with you. One is getting comfortable with anonymous methods or anonymous procedures or whatever you want to call them, or closures. And it's actually three, and callbacks in combination with them. And then the third thing is the parallel library that is rather new in Delphi. It's not that new anymore, but it's becoming more and more common being used. So if you want to find out more about iTask in future, look for the Embarcadero Parallel Library doc wiki right here, using the parallel programming library. Great examples and great stuff. Of course, the go-to book series for this kind of stuff, if you have like multi-threading, call her the queen of multi-threading, is Dalia Prajnica. She has 2 books just dedicated to this kind of topic area. One book is explaining the basics of these things, if you can even call this basics, right? But the foundation, let's call it foundation, because it's not basic, it's the foundation of everything. And then she wrote a second book where she looks at all the different classes in the RTL, VCL, and then basically tells you how to use them in multi-threading environment, and even if it's possible to use them, and if yes, how to use them, if it's not, what to do instead. Great book. That's literally, that helped me so much to implement certain things in VCL applications, how you guard your threads, how you basically release your threads correctly from memory. All those things are in that book, really, or in those 2 books, I should say. Good. So with that, you hear me breathing rather more deeply and laughing a little bit, because this has been a very complex explanation for how many lines of code? I think it's like not even 1 screen, maybe 2. Yeah. It's a lot of explanation for very little code, but it does so much, right? It achieves so much with so little code. It's great. And the type safety here with the generics adds to everything, that you can be assured that you get the right data back. The future is typed. The future is typed. Listen to that. But it's the future type is typed here with troot. And here the dictionary is typed with string to, where is it right here? String to troot. So everything is checked at compile time, which is really great. And that, believe it or not, completes the implementation of the backend. That's all there is. It's only this one method. It is really complex. It took me a whole day to get it right. And I didn't work 24/7 on it, but I worked on it a little bit. And I'm honest that it didn't work the first time, because I made the mistake not realizing that this callback call completes right away. So there's nothing to wait for. That cost me an hour. And then I had to think which concept to use to make sure that we are able to query if there is data inside of the data structure. And then also thinking of Nick Hodge's book, which explains the futures, I kind of came to this conclusion, checked with Wagner Landgraf if it was conceivable and if there are any side effects using XData with this kind of framework for the usage of the parallel library. Everything seems good to him. And then the final struggle was Swagger UI, which fails horribly because there's so many coordinates that are being returned. Using Fiddler helped me there and got me there in the end. So with that, our web server can start web server can be started. And the final piece of the puzzle is building now the user interface and then retrieving the data from the web service and showing it on screen. So we're not there yet, but we're getting closer. So hopefully this backend extravaganza was not too complicated. You liked that we looked at a little bit more non-trivial, more complex multi-threaded stuff. And now we get back to building the user interface with Bootstrap and just retrieving the data from the web service. The final part will be a little bit more complicated again, as we will generate the table for the driving instructions completely dynamically, still with Object Pascal, not using direct JavaScript or anything crazy like that, but still we have to know HTML rather well with Bootstrap to generate the table, because we're not going to use a predefined component because we want to custom build this from scratch.